All right, hello. My name is Nikolas Burk, and I want to quickly apologize up front. So I was sick the whole week. I stayed home on Wednesday, then I traveled here yesterday, felt a little bit better. Yesterday at the speakers dinner, I swear I only drank tea, no beer. But today it got a little bit worse again, so I apologize for that. I'm not as fast and energetic on stage as I would like to be today. But I'm really happy that so many of you are here at my talk today about GraphQL. And before we dive into the talk, I would like to get a feeling for the audience. So who here before this conference has heard of GraphQL? Okay, maybe it's easier to ask who has not heard of GraphQL before they got to this conference. Okay, still a couple of people, that's very nice. Okay, who has used GraphQL? Who played around with it maybe, or maybe even used it at their company? All right, still a couple of people. Who has used it in production? Nobody here yet, okay. In 1 year from now, next DevTernity conference, I want to see more hands going up when I ask the same question. Okay. Last question, who is a front-end engineer here? Couple of front-end people. Who's a back-end engineer? Okay, I have a small part for front-end engineers as well. I'll try to keep that one a little bit more brief then, because it seems that front-end engineers here today are the minority. So my talk today is about modern API design with GraphQL. And my name is Nikolas Burk, and I work as a developer at a company called GraphQL. We're based in Berlin. We're a small startup, and we're building a back-end development framework for GraphQL. And this is the agenda for today. So first I want to start with a brief GraphQL introduction, just so we're all on the same page about what GraphQL actually is and where it fits into your technology stack. Then I'll talk about the core concepts that you have to know when you're working with GraphQL. And then I'll have the section where I'll talk about how to use GraphQL on the front end, and then also a couple of notes on the architecture in general. So let's dive right in with the GraphQL introduction and the big question, what is GraphQL? Very, very briefly stated, it's a new API standard that was developed and open sourced by Facebook in 2015. And it's a query language that you use to send queries to an API. So it has the same suffix as SQL, so it's a query language, but it doesn't really have to do anything to do with a database. It really has to do something with APIs. It's an API technology, not a database technology. And that's a very common misconception that people have about GraphQL when they hear about it in the first place, because they only see the QL and they think, oh, it must be something that's related to databases. That's not the case, at least not necessarily. And it basically enables a declarative way of fetching and updating data against an API, and we're going to see what that means exactly. And GraphQL really has a rapidly growing community at the moment. So a lot of companies are already using GraphQL in production. So here you see GitHub, Twitter, Shopify, Pinterest, the New York Times, like really, really big companies who slowly transition their stack to GraphQL, and we'll actually see how the GitHub GraphQL API works. To really understand how GraphQL works, let's consider the simple example of a blogging application where we have the following profile screen for our users. So on top of the profile screen, we want to display the first name of the user, and then we want to show all the posts that that user has ever written. And finally, we also want to display who follows that user, but in particular, only the last 3 followers. So we don't want to show 100 or 1,000 followers. We only want to show the last 3 who followed that person. So how would we tackle this situation typically with the REST API? With the REST API, we would kind of design our server, our API like this, that we have 3 different endpoints where we can get information about the user from the user's ID endpoint. Then we can fetch all the posts for a user from the user's ID posts endpoint, and we can fetch all the followers from that user. And this, of course, is somewhat of a naive implementation, but we are going to go with this for this example for now. So if we now actually wanted to go and implement this profile screen on the front end, we actually would have to hit all of these 3 endpoints to gather the data that we need to display. So first, we need to hit the user's ID endpoint with a GET request, and the server might respond with data that looks like this. Again, depending on how exactly your API is designed, you might receive a different payload from the server. In this case, we're not only downloading the first name of the user that we want to display on the screen, but we're also downloading additional information. And here, we had a lot of people here who said they work rather on the server side, where you constantly have this trade-off. What do you include in the payload for a specific endpoint, and what do you leave out? And you have to make compromises here. So here we say that we have the address and a couple of more information about that user, which is not actually required in the app at that point in time. So we're downloading additional information that is not really needed. Let's move on and display the posts of the user. Again, we're sending a GET request, this time to the user's ID posts endpoint. And we're downloading an array of post objects. And again, depending on how your API is designed, you'll receive different information from the server. But again, this is not really desirable. It is going to slow down the performance of our app because we're downloading additional information, and it costs the user more money because we're putting weight on their data plan. But at least we have access to all the titles of the posts, and we can display them on the screen. And then lastly, we want to display the followers. So exactly the same. We have to go and hit the user's ID followers endpoint. The server might respond with data that looks like this, information about all the followers. We might receive more than only 3. So we have the ... which indicates that we could download more than that. But at least we know all the first names of the users and can display them. And of course, you can design your API in a bit of a smarter way so that it would cater to the needs for that particular screen. But if you really want to do that for all the different client applications that you might have mobile applications, and then you might have a web application. Maybe you have an application only for your customers. In the future, your fridge might have an application as well. So you can't cater all these different needs with one REST API. So let's now think about how we would tackle the same situation with a GraphQL API. And a really important point to understand about GraphQL in general is that when you have a set of endpoints with a REST API, where each endpoint is going to return a fixed structure of data, with GraphQL, you only have a single endpoint, and that single endpoint is going to return flexible structures of data. How does that work? Because the client can go ahead and actually submit what's called a query to the server and ask exactly for the data that is needed. So let's take a look at how that would work. Now we have the empty profile screen on the right and the GraphQL server on the empty profile screen on the left, GraphQL server on the right. And now the client would actually go and send a post request. So that's an important part as well, that we're commonly using HTTP post when we're working with GraphQL because we need more space in our request where we can put the query. And we usually put that into the body of the post request. And in the body of the post request, we might have a query that looks like this. So we're asking for a user with a given ID. Then we're asking for the name of that user, for the posts, but only for the title of the posts, and the last 3 followers, but really also only for the name. And you don't really have to understand yet why we can write that query in the way that we do and where all these words are coming from, but we can just acknowledge that we have a way to describe the data requirements on the front end that are going to be resolved by the server. So now the server is going to respond with with information that could look like this, where we have this object which is being returned with the root field, and then all the information that we're asking for, so user, name, posts, title, follower's name. So this is exactly the data that we formulate, the keywords that we also formulated in the query. And we receive all the data at once, so we can actually render a lot of it at once, or exactly all of it at once. All right, so now you have like a theoretical understanding of how this works. And now I want to show you the first practical part where we use the GitHub API. And we only had a couple of front-end people here, but who of the front-end people might already have used the GitHub REST API Or maybe people from the backend engineers? Nobody? One person? Okay, so this is really a horrible experience. This is not something what you want to be working with, and this is also one of the reasons why they were actually one of the first companies who jumped on the GraphQL train and provided a GraphQL API to get out of this problem zone. So here I have prepared what's called a GraphQL playground. And who of you knows what a tool like Postman or the advanced REST client is doing? Okay, so these kinds of tools basically allow you to send requests against your API and explore your API in an interactive manner. So you can send a request to a specific endpoint of your API with a specific payload, and then it'll just return the information. It's kind of like curl in the terminal or just plain HTTP in a nice application. And that's exactly what a GraphQL playground is, but it comes with a couple of additional benefits. So here on the left side, we write the query that we use, or which we want to send to the server. And then when we hit the play button, we'll see the response on the right side. And let's just see if that works right now. Okay, so here in the query which I sent, we just receive this payload. Viewer is actually a special keyword which is often used in GraphQL, which refers to the currently logged in user. And this playground has me as a user being authenticated, so now it returns my information when I send the queries. And one cool property of GraphQL is that you actually can see, oh, actually I'm going to show that later. For now, I just want to show you the repositories which I have. Let's take the first 50, for example. And you don't have to understand right now why I'm writing the query like this. It's just here I can ask about information from the repositories. And I can ask for the name. If there is a description, I can ask for the description. And we get all these nice features here, so I can exactly see inside the playground what kind of queries I actually can send. So I click the play button again. And now we receive the information about all my repositories. So here's one repository that's called WWDC with a description, Munich Watcher, UICon15. So a couple of repositories which we can retrieve with this query. So this really is the meat of GraphQL. This is how you can write queries. And now that you know that, you can already use GraphQL yourself on the front end. And what's also really nice is that GraphQL also has a couple of advantages on an organizational level, because you can give this playground to a non-technical person. You can give it to your product manager, to your UI designers, and they are going to understand how this works, and they don't have to mingle around with curl or a Postman, which are more geared towards a more technical audience. All right, let's go back to the slides and talk about the core concepts of GraphQL, and in particular, queries, mutations, and the GraphQL schema. So the first part to understand about queries is that queries only read data from the backend. What you saw on the slide before and what you saw on the playground, these were GraphQL queries that you can send to the server. So let's quickly understand how a GraphQL query is composed. What are the different components that we use to build up a GraphQL query? So at first, we have the operation type. We actually have 3 different kinds of operations in GraphQL, which are called query, mutation, and subscription. So if I wanted to send a mutation or a subscription instead, I would just replace query with the corresponding keyword. And because query is the default, I could actually also remove that here. Then we provide a name for the query, the operation name. Then we have a number of fields. The first field is called the root field, and we'll also learn why that is. And then the whole content of the query is called the selection set. So the whole collection of fields, including the arguments that we provide to the fields, is called the selection set of the query. And here again, we have a query, an example where we were asking for a message with a specific ID and the text and the name of the person who sent this message. and the server might respond with some data that looks like this. And again, it's really important to understand that the shape of the response matches the shape of the query. So we can somewhat think of a GraphQL query as an empty JSON object that we send over to the query, and the server is simply going to fill in the values for the keys in that empty JSON object. Now let's talk about mutations, because most of the time when you're working with an API, you also want to make changes to the state in the database, for example. So this in GraphQL is done with the concept of mutations. And what's really important to understand about mutations is that they not only write data, but they also, just like queries, can read data. So you can actually go ahead and submit a mutation, and you can treat it as a query in that you can, again, ask for all the data that has changed due to the mutation. And here we have a very simple mutation, and again, we have exactly the same components as with the query. So mutation is the operation type, then create message mutation in this case is the operation name. Then we have two fields, create message is the root field, and ID is the only field of the new message that we're asking for. And the server might respond with information that looks like this. So again, the shape of the response exactly matches the shape of the query. The client can dictate the format of the response that is going to be returned by the server. And now let's talk about the GraphQL schema. How is all that possible? Where or who dictates what the terms are that we can put into a query or into a mutation? That is all written down in the GraphQL schema. And the first thing to note about the GraphQL schema is that it is strongly typed, and it's written in what's called the schema definition language, the SDL. And basically, the GraphQL schema defines the capabilities of the API. So there you really have a very strong contract for client-server communication. Maybe you've used a tool like Swagger before, where you could also set up a contract for client-server communication. But I don't know what your experience with Swagger was, if it always worked in the way you want it to work, if it really gives you that protection. The GraphQL schema is a very, very strong concept that sits at the core of your server, and that your server and all your client applications are going to be aware of, so everybody at all times always know what the API is going to look like. And the GraphQL schema basically is just a collection of types that are written in the GraphQL SDL, but it has three special root types that are called query, mutation, and subscription. And if you've paid attention before, you know that these are exactly the three operation types that we have in GraphQL. So let's look at an example what types in the SDL actually look like. So here we have two simple types. One is called message and one is called person. And then each of these types has one field at the moment. We have a text field that is of type string, and person and the name field on the person type that is also on type string. And the exclamation point that follows the type just means that this field is required on every instance that is going to be created of that type. We can also add relations between types. So now we're adding a one-way relation from the message type to the person type to indicate that every message always is sent by a person. And if we wanted to make that relation two-directional, then we can add the corresponding messages field on the person type as well. Now let's talk about the root types. So we know now how we can use the SDL to define simple types, but I told you before that every GraphQL schema has three special types: query, mutation, and subscription. So how do we have to write these types in our schema, in our contract, so that we can expose certain capabilities, so that our clients know what kind of queries and mutations they can actually write? So let's assume we have the same query that we saw before, where we were asking for a specific message with the text and the name of the person who sent it. So what does the GraphQL schema now has to look like? What does the query type now have to look like so a client application is going to be able to send that query? Well, we would have to add the root field of the query, so the field called message, as a field to the query type. Yeah, it's really important that every root field in every query is a field on the query type in our GraphQL schema. If we wanted to add the capability to ask for all the messages which we currently have in the backend, we could send a query, or we could define a query that looks like this with all messages. And again, this would mean that we have to add the all messages field to the query type in our schema. And we have exactly the same situation for mutations. So if we wanted to have a create message mutation that looked like this, we have to go and add the corresponding root field to the mutation type. And just to complete the API for the message type and really have CRUD operations for creating, reading, updating, and deleting messages, let's also go ahead and add an update message field and a delete message field. So now we're taking a look at the full schema. So again, we've got the message and the person type that we saw initially. And then we have the query and the mutation type. And this schema by itself now defines the API of a GraphQL server. Well, kind of. At the moment, we actually only have a CRUD API for the message type. If a GraphQL server exposed this kind of API, we couldn't do anything with persons yet, so we would have to add the same fields to the query and the mutation type as well. Okay, so now let's try to understand the difference of structure versus behavior in GraphQL. Because so far, we only talked about the GraphQL schema and basically the types and its capabilities. So we were talking about the abstract representation of the schema. And really, the schema definition language, which we saw before, they only defined the structure, right? It was the abstract representation of the API that we can take a look at, and then we kind of understand, aha, so we can send this query to the API because the field is on the query type. We have this root field, so we can send the corresponding query to the server. But then how is that actually implemented? And I know we have a lot of backend engineers here, so you want to know how this works under the covers now. And this is what we do with resolver functions. Resolver functions, they are the concrete implementation of the GraphQL schema. And usually, if you take the abstract representation in the form of the SDL and the resolver functions, if you take that together, we kind of talk about this as an executable schema. So what are these resolver functions? First, it's important to know that each field in the GraphQL schema is backed by a resolver function. So exactly as many fields you have in your GraphQL schema, not only on the query and on the mutation type, but also on the person and the message type, for example, for each of these fields, you need to have one resolver functions in your actual implementation. And the type of a resolver function is identical to the type of the field. That means that the return value or the return type of the resolver function is the same type that the field actually is, and we'll see what that means in just a bit. And then basically all a GraphQL server has to do when a query arrives, because a query is just a collection of GraphQL fields as we learned, and each field has a resolver function, and I should say that each resolver knows how to fetch the data for that specific field. So the name field on the person type knows how to get the name for the person that is being asked for. So really all the GraphQL server, or rather the GraphQL engine, has to do to resolve a query is to call all the resolver functions that are part of the query. And that's one reason why GraphQL is sometimes compared to remote procedure call-like systems, where you also have the ability to invoke a remote function that is sitting basically somewhere on a server, because with GraphQL, you basically do the same. You send over a query, but this query just leads to a number of function calls on the backend. So if we take the example from before with our not quite complete API, we would have the following resolver functions. We would have a resolver function that is called message that would return a message. all messages would return an array of messages. Down here, the name resolver for the person type would return a string. So that's what I meant by the return type of the resolver function is identical to the type of the corresponding field. And now let's take the same example that we saw before with the query where we're asking for one specific message and see how a GraphQL engine would now execute and collect the data for that particular query. So at first, it would go ahead and create like the overall empty response object that it wants to return. And it has one root field that is called data, and that's what's written in the GraphQL specification. And at this point, I should mention that GraphQL itself is actually only a specification. That means it's not more than a long document that you can look up on the web, which describes in detail the formal language of GraphQL and how a GraphQL server has to behave, right? It's really only just a specification, so you can actually go ahead and use GraphQL with any technology, any programming language of your choice, because you can just go and take a look at the specification, take your favorite programming language, and implement the specification. And in fact, this is what a lot of people have done already, so you'll find a lot of reference implementations for GraphQL in various languages. But again, back to our example, where we just received this query here, and we now want to see how that data is resolved. So we have the empty response object, and now because we've got the root field, at first what the GraphQL engine has to do, it has to invoke the resolver for this field. And for now, the resolver is only going to create the empty message in the response. Now we're calling the resolver for the text field in the query. And this time we're actually getting information back, so we're not creating an empty object in the response, but instead we might have hit we might hit the database or something like this. So now we receive some text, can put the text into the response. And now we want to know who is the person who sent that message, so we call the resolver for the send by field. And because we don't actually get any data from that, we just create that empty object. And then finally, we call the resolver for the name field. And again, this time we actually received some data. Cool. All right. So in this demo, I want to show 3 different things. At first, I want to talk about plain GraphQL. So what does that mean? I just explained that GraphQL is only a specification, and in fact, in that specification, you have no notion of a network layer or a transport layer. So really what this only explains is how GraphQL actually works under the hood, but the specification, the official specification, doesn't care how a GraphQL server is going to receive the query. So you can use HTTP, you can use WebSockets, you can use any transport that you like. You could use like MQTT. You can use all these different technologies that you can use to send information over a network to implement your GraphQL server. GraphQL won't care, and I want to show you an example where we don't have a network layer at all. So that's what I refer to with GraphQL, with plain GraphQL. Then I want to show you how you can use GraphQL with HTTP with a library that is called GraphQL Yoga, which is a small wrapper on top of Express.js, if you've used that before. And then I also want to show you how you can use GraphQL for an auto-generated CRUD API based on a data model that you provide. All right. So let's jump into the demo again. And let's take a look at the code. I'll increase the font size a little bit. So here we don't have a database that is connected. We just have a very simple source of data. We have an array with 2 users, which both have an ID and a name. And then we are exporting this fetch user by ID function. So we don't have an actual data layer here. But here is the interesting part. So here I'm using actually the GraphQL JavaScript reference implementation that was open sourced by Facebook alongside the specification. So because Facebook had an interest that people were going to start using GraphQL when they open sourced the specification, they also created this reference implementation so that people could get started right away. And here is the important part where we define this GraphQL schema object, and this actually refers to the root field query. So before on the slides, we had this type query with all the root fields that we could use for our queries that we wanted to send. And here we have a similar representation, or the same representation, but in the form of a JavaScript object. So the name of the type that we are creating is called query. It has a number of fields, and most notably, it has this user field that is of type user that can take a number of which can also take a number of arguments. And to show you what this would be equivalent in the schema definition language, it basically means this. It's just a different representation of this. So we have the ID. That is, oh, actually, sorry. So the user fields with the ID as an argument is the same representation, but here we also have not only the abstract structure, we also have the resolver function, which is attached to the field right away. So this resolver also at the same time now, the field already has its resolver function. So, oops, let me delete this again. Okay. And here we actually also create the user object. I just want to quickly show you that we can now send a query against this. So here I write the query. I provide an ID. Let's do the ABC ID, where we know this belongs to the user Sarah. And here I'm using the execute function. I'm passing in this schema, the executable schema, which knows what kind of queries we can send, and a parsed version of the query which I defined here. So we don't have a network layer here. We only have this GraphQL engine, and we're sending to it this query based on the schema which we define up here. So now I call yarn start to invoke my node script. And here we see that we receive this JSON object from the GraphQL engine. So because the GraphQL engine only called all the fields for the resolver functions for the fields that are contained in the query, so it calls the user ID, and the username field. And to quickly show you again, here we had the user type, which was also part of our schema, and it has an ID and a name field, and both again have a resolve function attached to it, which are called when a query is received. All right, now I want to show you a somewhat better version of what we just saw with a library that is called GraphQL tools. And what was a little bit annoying in the version which I just showed you, that we didn't have this advantage of using the schema definition language. So the schema language is actually a very nice way to express and write down the capabilities of our API, but we didn't use it. We had to write this cryptic JavaScript object that was kind of hard to grasp. So the GraphQL tools library is going to help you with that and enable you to build your GraphQL schema object that you can pass into the engine based on the SDL, on the GraphQL schema language, by actually writing the types like this. So again, we've got the same situation as before with our with the capabilities of our API, and then we have resolver functions. And in these resolver functions, we just follow the structure of our types in the type definitions here. So we have the query type, and the query type has a user field, and we write the resolver functions for this. Then we're calling make executable schema, which we import from GraphQL tools, as I said. So we put this together with our type defs and the resolvers. And now GraphQL tools under the cover is going to take care of actually creating this GraphQL schema object that we saw before in the previous version, where we only use the reference implementation. The code here is exactly the same as before. It'll just execute a query against the schema that we defined up there. So let's go ahead and write a query. Maybe we don't pass the ID this time and wait what is happening because we pass an empty string as an ID. So here we actually don't receive any sensible data or expect any sensible data from the server, from the engine. We don't have a server yet. And we see that now a user is returned, which is just null. And that's kind of as expected because we don't have a user in here that has an empty array, a string as its ID. All right, so now we know how GraphQL can work without a network layer. So this is really just the inner workings of a GraphQL server. And it won't really care yet how the query is received and how it has to send the response. So here we use Yoga demo now to see how we can do this with an actual HTTP server. Again, I want to quickly show you the code that I'm using. And it's again based on the same GraphQL schema that we just saw in the plain GraphQL version. So we have this users array, and in the index.js file, this looks very much the same as what we just saw with GraphQL tools. So we're defining the capabilities of our API in terms of the schema definition language. Then we are writing the resolvers that know how to fetch the data. And then finally, we're creating this GraphQL server, which we import from the GraphQL Yoga library. And then we can go ahead and start the server. So this is all we have to do to go from the plain GraphQL version to the network version. I'm going to start the server here. It's now running on my local host. And I can go ahead and use the same queries that we saw before. It tells me I have to provide an ID argument. So now we get the same information because we don't have a user with an empty string as an ID. But as soon as I put this, we'll actually get the user back. All right. Now, if you don't want to go and build your GraphQL server there yourself, you can also use the GraphQL service, which I have also prepared an example. So when you're using GraphQL, you're starting out with this root configuration file, which is called graphql.yaml. And here, it points to a file that is called types.graphql, where we can define a data model. And here, our data model basically looks like this, that we want to define a post type that could be the foundation for a simple application for sharing images, for example. And it has an ID, it has a created @, field, updated @ field, description, and an image URL. And if you now want to have a GraphQL API just based on this data model, you basically only have to call GraphQL deploy, then ask a couple of reply to a couple of questions, and the server is going to be deployed, and it will expose a CRUD API exactly for the data model that you just described. And to prove to you that we actually have here a GraphQL schema, I just want to show you what the schema looks like for the API that we now have here. Yeah. So I now have downloaded the schema.graphql file. And here is the schema that is generated for you based on the data model that you created. And the most important part, let's go ahead and skip to the query type. Here is the query type, which defines what kinds of queries we can send to the API. And you'll notice, let me increase the font size a bit, that it looks very similar to what we saw on the slides before, except that we also generate ways for you to filter and sort and all of that kind of stuff. But we have this query which is called all posts, and the post to ask for a particular post, and then the mutation type for creating, updating, and deleting posts as well. Now let's see how that API actually works. So I can also go and open it inside a playground. And I'm going to create my first post here. Rare look into the GraphQL office. And we have an image URL for that one as well. Let me quickly find it. So now the post was created in the database. Here I can actually go and now send the all post query to see that this actually worked. So now we receive this information back from the database. So we actually have a GraphQL server with a connected data base here. And now I want to go back to the slides. So now we have an understanding of how we can use this auto-generated CRUD API. So now I quickly want to talk about GraphQL on the front end and the concept of a GraphQL client. So GraphQL clients in general are basically just a convenience way for you to interact with the GraphQL API when you're writing an application. So we saw that we can just use plain HTTP to interact with a GraphQL API when it has a GraphQL server, but these GraphQL client libraries, they will make it really easy for you on the front end when you're writing your application. So basically, they provide a convenience API for sending queries and mutations. And they also, or like the more sophisticated ones, and we have two bigger GraphQL clients that I'll talk about in a second, also completely take care of caching for you. And they implement more handy features like optimistic UI, all the lower level networking stuff, real-time functionality with subscriptions, maybe support for more features which you can have as well in your app. And we have two big GraphQL clients at the moment, which are called Relay and Apollo client. And Relay is Facebook's homegrown GraphQL client that was open source alongside GraphQL in 2015. It's really heavily optimized for performance and to reduce network traffic. And it also comes with a notable learning curve. So if you're just starting out with GraphQL, Relay might not be the best choice for you to get started. There, Apollo has a much better approach. It's a very community-driven project, completely open source as well. It's easy to understand with very intuitive abstractions, and it's available on several platforms. So while Relay can only be used with JavaScript, with Apollo client, you can actually use it also on the native mobile platforms, and they have bindings in JavaScript for all the major frameworks, so you can use it not only with React, but also Angular, Vue.js, whatever you prefer. And basically, what this enables is to go from an imperative to a declarative data fetching approach, where imperative data fetching can be summarized with these 4 steps. So you kind of have to construct and send the HTTP request, for example, with fetch in JavaScript. Then you have to receive and parse the response from the server. Then you have to somehow store the data locally in your cache with Redux, for example. And then finally, you can display it in the UI. But you have to do a lot of work in between. With declarative data fetching, you basically only pass your data requirements to the GraphQL client, and then you display the information in the UI. And I have a demo for that. I don't think that I have a lot of time left, so I'll skip this demo. If you want to try it yourself, you can go to this link. It looks like this, and it will use the same data model that I just showed you when I created the CRUD API, so we won't actually have the look into the GraphQL office right now. I quickly want to talk about architecture because we have so many backend engineers here, and I think this is really a point that you're going to be interested in. So we kind of distinguish between 2 major ways of using GraphQL. The first one would be GraphQL native, which are applications that are kind of designed from the ground up to use GraphQL, where GraphQL really is used as an abstraction layer on top of a database. So nobody likes writing SQL. And I hope, or I'm not sure if I have the right audience for actually saying that, but it can be really a pain to write SQL. And GraphQL just has a much, much nicer interface for defining a schema and for extracting information from your database. So just use GraphQL as an abstraction on top of a SQL database, for example. And it's really an ideal way to work with greenfield projects. And it kind of looks like this, where we have the database, then a GraphQL API on top of that, and then our clients communicate with this. But a more interesting and compelling use case, and also the initial use case that Facebook had when they developed GraphQL, is this concept of an API gateway. And there, GraphQL really is used as a proxy layer for existing APIs. So it's going to unify a number of different APIs and hide them behind one single endpoint, so our clients have a nice way of working with a number of different systems. In the API gateway, you would put your business logic, authentication logic, permissions, caching, logging, all the features which you need in your app. And you can go ahead and actually, if you have multiple GraphQL APIs that you want to unify, you can use a very new tool that is called schema stitching. So if you follow what's going on in the GraphQL community at the moment, schema stitching is the hot topic at the moment. And with the API gateway, it kind of looks like this. So we have one GraphQL API, and we don't really care where the data is coming from that we're exposing. So we could have a connected database, we could have a REST API, we could have a third-party API like Stripe or Yelp. We can integrate these different services. And in fact, with schema stitching, if all of these have GraphQL APIs as well, you can just very easily combine them. And again, your client applications, they work with a single endpoint, with a single API, and all the complexity of resolving these data requirements is resolved on the server side. And you could, for example, build an application like this, where you could integrate the GitHub API with a GraphQL API of yours and with the Yelp API to compare your favorite coders and see if they also have restaurants and see if their restaurants or their repositories have more stars. That's all I have, so I quickly want to finish with a couple of resources that I want to recommend. So if you want to learn more about GraphQL, the How to GraphQL full stack tutorial website is a really great place to start. If you want to stay up to date about what's happening in the GraphQL ecosystem, then you can subscribe to the GraphQL weekly newsletter or the GraphQL radio podcast. At GraphQL, we really value community. If you want to chat about GraphQL, you should join our Slack, which is the biggest GraphQL Slack in the world, even bigger than the actual GraphQL Slack. And we host the GraphQL Berlin meetup. If you're ever around, make sure to come. And we're also hosting the GraphQL Europe conference with an expected number of 500 to 600 attendees next year in June. That's all I have today. Thank you so much.
Thank you, Nikolas. And yeah, we have many questions, actually. Okay. And as you predicted, the first question is, why not SQL?
Well, I just would say that simpler abstractions are usually nicer. And GraphQL is just like a very, very simple abstraction for working with data. And it's of course a matter of personal preference, what kind of abstractions you prefer. But I think that if you want to easily work with a database, then GraphQL is such a nice way to work with data that it feels kind of overly complicated if you actually have to write these SQL queries yourself. So might be a matter of personal preference. If you really, really, really like working with SQL, that's fine. But the simplicity of GraphQL, I think, is a very compelling argument why you would want to use GraphQL as an abstraction over your database.
Can you actually do joins?
Well, the joins are happening under the hood, right? I mean, so you only expose the data with GraphQL, but under the hood, you're still using SQL. Maybe I haven't... Sorry? Well, maybe I haven't made that point clear enough.
There's so many features in SQL.
Sorry?
Unions as well. And
well, so when you're using GraphQL as an abstraction over your database, depending on what kind of database you're actually using, you still actually have to write SQL when you're actually implementing that. You could use GraphQL, so this is basically our main value proposition, that when you're using GraphQL, we are managing all that SQL stack for you, and we're exposing everything through GraphQL. If you wanted to implement that yourself, and you want your clients and everybody to be able to use GraphQL for your API, you would still have to write SQL, or if you're using Mongo, you would still have to access this database. That's what I meant initially when I said GraphQL is not a database technology, it's an API technology. So there is not really this database layer with actual storage. It's just a layer on top to expose the data from the database. So you still need an actual database under the hood. At GraphQL, we're using a SQL database under the hood. We're writing the SQL for you, so you don't have to.
Okay. Yeah, there's another question. How should the response be generated if part of the requested data should be denied based on some permission?
That's a really, really good question. So how do you deal with permissions and authentication and all that kind of stuff? So the first thing that I have to say about this, that the GraphQL specification itself doesn't actually tell you how to deal with permissions. They tell you how to deal with situations when things go wrong, because then you can return a partial result for the query. So if you have a query that has an ID field, which asks for an ID and the name of a user, but the person who's submitting the request only has access to the name but not to the ID, then the server could return only the name, the ID would be empty, and then you have to also return an array of failure information about what went wrong. So there you would actually go and put the information and say that the ID field cannot be returned because the current user didn't have access to it. So the client, it will receive the data that it had access to, and at the same time it will also know what went wrong because that information is also contained in the response.
Okay, yeah, maybe two last questions because actually we're already out of time. How does the API versioning work in GraphQL?
Also a really, really good question. So again, same answer. The GraphQL specification doesn't have an answer to this. But generally, because you're using the GraphQL schema as the core for your API and its capabilities, and the client and the server are going to be aware of the capabilities of the API, and at all times when you're making changes to the GraphQL schema on the backend, these changes need to be propagated to the client applications. And when you then deploy a new version of a client, it knows what kind of queries it can send. If you want to make changes to the schema, then what you can do, of course, when you add new fields, this is not a problem at all. It's more about when you remove fields or rename fields from the current schema. And there, you can take advantage of the mechanics of GraphQL, where basically on the server, you can always see what kinds of fields are being requested often. Because when a field is requested, you know that the resolver function for that field is called. So you have a very, very nice insight into what fields are being requested from your clients. And you can actually go ahead and deprecate certain fields, which you can also note in the schema with special information that you can provide for these fields. And then your client applications can become aware that a certain field might be deprecated in the future. And once you see that no clients are accessing this field anymore, then you can just remove it from the schema.
Okay. Yeah, okay, last question, because it gets a lot of votes. What protections are there against injection attacks? GraphQL injection.
Same answer. GraphQL, the specification, won't tell you anything about this. So it's always up to you how you implement your server. GraphQL itself doesn't free you from thinking about all these kinds of problems. You still
but what about the implementation that you mentioned
with GraphQL?
Yeah.
So we, for example, have like a limit that you cannot send nested queries that are like nested more than 3 levels, for example. So we have a couple of protection mechanisms which are built in. So if you want to know more about that, you can come and ask me later. I think we're already...
Yeah, we're out of time. Thank you very much. And
thank you.